we present our work titled HDR Video Reconstruction, a coarse-to-fine network and a real-world benchmark dataset. Compared with standard dynamic range images, high dynamic range images can better reflect the visual details of a scene in both bright and dark regions. However, due to the limited dynamic range of the sensor, a single exposure cannot capture the full details of a high dynamic scene. A low exposure image contains noise in the dark region, while a high exposure image cannot preserve the details of the highlight. Successful methods for HDR video reconstruction often rely on customized equipments, which are costly. A low-cost direction is using sequences with alternating exposures. However, existing methods often rely on optical flow alignment and suffer from ghosting artifacts. In this work, we build upon existing reconstruction methods using sequences with alternating exposures. Rather than merely using optical flow for image alignment, we introduce a coarse-to-fine network for better alignment and fusion. In addition, a real-world video dataset is introduced for comprehensive evaluation. We first introduce the network architecture of our method. Our method contains two stages, and we take a two-exposure scene to illustrate it. The first stage, called CoarseNet, performs alignment and fusion in image space. It takes 3 low dynamic range images as input to estimate the coarse HDR image. Given 5 sequential images, CoarseNet can reconstruct HDRs of the middle 3 frames. The second stage, called RefineNet, performs alignment and fusion in feature space. It takes 3 coarse HDRs as input and produced a refined HDR of the centered frame. Our CoarseNet aligns images using optical flow, and perform pixel blending to obtain the HDR image. Our RefineNet first extracts a feature for each coarse HDR image. It then aligns features of neighboring frames to the centered frame using deformable alignment module. The aligned features are then fused using temporal attention. Last, the fused feature is used to regress the refined HDR. We introduce a benchmark dataset for this problem to enable comprehensive evaluation. The captured videos have a frame rate of 26 FPS, and a 4K resolution. 3 different types of video data are captured, namely, static scenes, dynamic scenes, and dynamic scenes without GT. This slide shows samples in the static scenes. This slide shows samples in the dynamic scenes. This slide shows samples in the dynamic scenes without GT. Let's look at some experimental results. PSNR, HDR-VDP2 and HDR-VQM metrics are measured. We quantitatively compared our method with existing methods introduced dataset. This slide summarizes the results on the static scene dataset augmented with global motion. Red color in the table indicates the best result. This slide shows the results on the dynamic scenes dataset. It can be clearly seen that our method achieves the best results. We then show qualitative results on Calantari's dataset. Results on a fire scene. Result on the 3 exposure checking email scene. Result on the 3 exposure dog scene. Thank you for watching.